大家好，非常高兴看到这么热烈。我刚开始还有一点担心说，不知道这个会有这么多人来哈。那我是清华大学电资学院的院长徐硕宏。那我们非常高兴今天有这个机会，请到我们这个重量级的这个演讲者MarkChen。那大家可能会，昨天我遇到一个同事，他们非常好奇，说我们怎么请得到这个 OpenAI 3大研究部门之一的主管那他也是一个我们这个 ChatGPT 现在最热门的这个 Key Person 之一那事实上他就是我们资工系资应所所长邱进德邱老师的公子邱老师要不要站起来跟大家这个？事实上，真的确实是因为这个关系，所以我们才有办法请得到这么重量级的贵宾那当然，我本身跟这个 Mark 也有一些渊源我记得他小时候，因为他现在还很小Mark 才30岁出头而已所以大家讲英雄出少年真的是30岁出头而已。他高中的时候我去过他们家，然后他弹钢琴给我听，我印象非常深刻，一直记到现在。那他那时候我记得跟我说 SAT 考满分那他跟清大也是很有渊源他事实上有来过我们清大那时候高中就来修一些很困难的大学的课程那今天赵启超老师可能等一下会来，他是以前帮他教过他的离散数学，有一些蛮困难的课程所以广义上 Mark 也算是我们的校友了好。那等一下我会正式介绍Mark 的这个一些 presentation 的他的 resume 跟这个今天 present 的这个内容。那在这个之前，我们先 present 一下我们的 gift。那今天校长本来要来，那校长因为有一个重要的签约仪式，所以没办法来，但他有准备这个礼物。来 ，Mark 要不要请你上来？我们先。那这个礼物我先稍微讲一下 ，before 校长准备了一个清华的锦旗这个很重要那还有一台是这个咖啡豆，是我们清大的校友发明的这个全世界第一台的微波烘豆机烘出来的咖啡豆那我们院也准备了礼物，就是我们这个梅园的这个梅子酿出来的酒。还有一罐这个梅园的梅子Plum Garden 的这个蜜饯好，来。All right, so now I will give a brief introduction to MarkChen. And MarkChen is the head of multimodal and frontiers research at OpenAI. He graduated from MIT with a bachelor's degree in mathematics with computer science. He contributed to the development of GPT-3 and created Image GPT. And he led the teams that produced DALL-E 2 and introduced version to GPT-4. And by the way, DALL-E 2 is a big step for next image generation, giving a prompt to generate original, realistic photos that combines concepts, attributes, and styles. Applications include in-painting, out-painting variations for designers, video games, urban planning, etc. And Mark, as a research scientist at OpenAI, he also led the development of Codex, which is the AI system that powers GitHub's GitHub Copilot. And Codex OpenAI parses natural language and generates codes in response. Codex is a descendant of OpenAI's GPT-3 model and fine-tuned for use for programming applications. And he led the work and published the paper evaluating large language models trained on code on July 2021. And former quantitative trader, he's also a former quantitative trader before he joined OpenAI at several proprietary trading firms. Actually, it's in Wall Street, so it's a big finance companies. So including James Street Capital, and where he builds machine learning algorithms for equities and futures trading. And it's a very unique job Mark doing is he's the coach for the USA Computing Olympiad team. All right, so the talk Mark will offer later is he will give a look into how ChatGPT was created and begin with an introduction to GPT models and the reasons OpenAI invested so heavily in them, with a focus on compression and scaling laws. And he delved into the use of reinforcement learning from human feedback to transform these GPT models into user-friendly ChatGPT models. And then finally, end with a discussion of how ChatGPT can be trained to use external tools, such as a browser. All right, so let's welcome Mark to give us this talk.
Yeah, thank you very much for that kind introduction. Thank you for inviting me, Dean Shu, President, of course. And thank you all for coming here today to see the talk. Just before I get started, how many of you guys have used ChatGPT before? Oh, great. That's really encouraging to see. And how many of you have any knowledge of transformer architecture? Okay. How many of you have trained your own transformers and written them up in PyTorch? Oh, great. Okay, cool. I think this talk is at the right level, so let's just get started. So my original title of the talk was From Compression to ChatGPT. And I realized after some time, I only have 30 minutes to give a talk, so I used some compression, and now we're just really gonna talk about ChatGPT today. I think compression itself could be another half-hour talk. So I've taken the liberty to change the title to Getting the Most Out of GPT. And I think one of the lessons that I really want you to take away today is that these GPT models are behaving more and more like humans. And sometimes you can coax a lot of abilities by kind of treating them as if they are a kind of agents that you could talk to, almost like a human counterpart. So let's start with what is GPT? At its core, GPT is a very simple idea, right? It's all built on next word prediction. And it's a model, a probabilistic model, that takes a bunch of words as a prefix and then calculates a distribution over probabilities for the next word. So we model the probability of the next word given all the previous words. For instance, if you have a sentence, you would decompose the probability of the sentence into the probability of the first word times the probability of the second word given the first word times probability of the third word given first and second word, and so on. And the reason we do this decomposition is, there's over 100,000 words in the English language, right? And what we're doing is we're trying to constrain the output space so that we don't have combinatorial blow up in terms of what we're modeling. So one cool thing you can do about language models is that it can complete a sentence that you start, right? And I can show you an example here. This is called prompting. So when GPT-2 first came out, this was the result that really kind of blew me away. And you can see an example of prompting here. When you give what's highlighted in yellow to the model produces the text that's written in white. So you have some controllability off the bat. So here, the prompt is, in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. Right, and you can see the completion, it makes sense, right? They talk about an evolutionary biologist named George Perez. So this is very, very fitting to the prompt, right? It really kind of understands what the setting is and tries to create characters that are consistent with the setting. But even more importantly, what GPT-2 really taught us was that almost every single task can be described using language. And so this model, even though it was trained to do no task in particular, it is able to do every task that can be described in language. So for instance, we used to have machine learning benchmarks that are question and answering benchmarks. And usually it would have a passage and then some questions and you would have to answer in natural language. And what we can frame this as is a prompt, right? You can copy the entire context into the ChatGPT prompt. You ask a question, and then to coax an answer out, you can put answer colon, right? And the model should understand that its task is to produce an answer in this situation. Now, jumping forward to GPT-3, we really see the importance of scale. So GPT-2, it was just a couple billion parameters. GPT-3 took it another 100x in terms of parameter count. So what you're seeing on the x-axis here is number of parameters. And on the right axis, you're seeing the ability of a human to detect the difference between a computer-generated text and human-generated text in this specific domain of generated news articles. And you can see that as the models get bigger, it becomes harder and harder for humans to distinguish between what's real and what's fake. And GPT-3, as a milestone, was one of the models that was first very close to being able to fool humans, which is this 50% random chance bar right here. So capability-wise, that is what GPT was able to accomplish. But one other insight that we had with GPT-3 was that new tasks can be described in context. What I mean here is, even if the model has never seen this task before in pre-training, we are able to, within the context or the prompt that we provide to the model, specify a task that the model has never seen before. And the model should pick up what is required of it as it processes these characters. So here, I made up a task. I have some English words, and then I insert garbage characters into the words, right? So I'm adding some exclamation marks, some slashes, and the idea is we want the model to be able to remove these words, these characters, and produce the actual English word. So if we give the model a couple of examples, we find that the model is able to generalize to some new example here. And even though it's never seen these types of examples in the training data before. So this kind of in-context learning, first of all, gets much better as you scale the model size. And secondly, the number of examples in context. You can see that it's learning as it sees more and more examples. This is the x-axis here. As you show more examples, it's learning by seeing these examples and getting better performance within the same model size. And of course, earlier this year, we released GPT-4. And this was our latest experiment in scaling the models. Now, the reason that we've scaled these models isn't just kind of throwing a bunch of compute and kind of hoping that good behavior emerges. We found that we can very accurately predict the performance characteristics of models as we scale them. So it's actually a very precise formula. We know when we train GPT-4, is it matching up with expectations or not? And what we were finding was GPT-4 is a much better reasoner than previous models. So you can see that in a bunch of these standardized examinations for the United States, the model is oftentimes able to score in the roughly 90th percentile of human test takers. And this is versus GPT-3, which often is in the 10 to 50th percentile. So we're seeing big improvements in specific reasoning style data sets. Another thing that we did with GPT-4, and some of my teams were responsible for putting this in, was introducing vision into the models. So the models are able to take visual inputs like pictures, and it's able to process the text. I think in the most basic level, it's able to do OCR and just convert the text into natural text. But you can also ask some questions. So you can, let's say, give this chart, and then ask the question, what's the sum of the average daily meat consumption for, let's say, Georgia and Western Asia? And it's able to read these numbers, the 79.84, 69.62, and actually do some mathematics here, right? And even further, these models can use all the base capabilities of GPT models, right? So they have all the language understanding that GPT-4 does, and we can even produce a physics problem in a different language, ask the model to think about the solution, and it will generate the solution for you in English. This model is also able to explain jokes to people. So this is a kind of typically cited meme of how deep learning has nothing novel, we just scale layers to infinity. But the model understands what we're doing. It says the humor comes from the contrast between the complexity and specificity of statistical learning versus the simplicity and generality of the neural network approach. Right? So it's able to take these oftentimes like humorous things which humans contextualize and understand why it's funny and explain it to us. So now I'm going to talk about how GPT becomes ChatGPT. So language models, what they're trained to do is predict the next word. They're not trained to be helpful. So if you have a prompt that says, explain the moon landing to a 6-year-old in a few sentences, and you just run a GPT model, it's not going to give you what you want. So it's going to say, okay, what's the most likely text that comes after? And in many online news articles, they're just lists of questions, right? So it might say something like, oh, now explain the theory of gravity to a 6-year-old. Explain the theory of relativity. So this isn't really what you want, right? The human wants, people went to the moon, they took pictures and sent them back to Earth so we can all see them. So our solution here is to use this technique called reinforcement learning from human feedback. And what this does is it uses a small amount of feedback to teach the model how to achieve a goal without having a human to hard code what the goal is. So here is the interface that we provide to a human, for instance, to teach a little stick figure how to do a backflip. And in each case, all the human has to do is say, is the left side better or is the right side better? Okay, they don't have to say what is a backflip, right? That's actually very difficult to specify because maybe there's something about the center and maybe the side moving in a circular motion. So that you don't have to specify at all. And you can see that just simply by rating, roughly 50 comparisons, we can teach a model to produce this backflip motion without actually having to say what a backflip is. And so this is a very powerful way of learning from just a small number of examples. Now, how do we apply this same kind of idea to language models? Well, reinforcement learning from human feedback at scale. So we want to run this at a larger scale than just having humans sit there and click which language completion is better. So what do we do here? Well, we train a model to mimic the preferences of the human. So what we do is we have a GPT model, it produces some responses, and then we train a reward model that kind of tells you how good the response is from a human perspective. In this way, we can replace the human with the reward model, and the reward model is scoring instead of humans kind of sitting there clicking. So here's the pipeline. And the reason we use RLHF for language models is that aligning a language model and having it do what you want, that's a very fuzzy goal, right? What does it mean for the model to follow my instructions perfectly? The right way to do it is to show it a bunch of examples and say, hey, this one looks a little bit more correct to me, right? So what we do is first we collect comparison data and train a reward model. So we have the model produce several responses to explain the moon landing to a 6-year-old. And then we have real humans create a ranking of the preferences across the responses. And then this is used to train our reward model. So this reward model will learn the same preference model as the humans. And then now we can optimize against this reward model. We use an algorithm called PPO. And it uses this reward model to provide scores for the different outputs. And then this is fed back into the model to improve it. So the way that people generally score language completions is known as the Likert score. It's a number between 1 through 7. And it's literally you ask a human, hey, was this response what you wanted? Can you rank it from 1 to 7? And you can see that a GPT model, if you don't do any reinforcement learning from human feedback, the Likert scores usually hover a little bit over 2 out of 7, pretty bad. But after the RLHF procedure, you're bringing it up to oftentimes more than 5 out of 7. So we see that running RLHF really improves the usability of these models, especially from a human perspective. And this is also able to mitigate a lot of other side effects that we care about with language modeling, right? So there's toxicity, like are the responses kind of toxic? Do they reflect kind of bad behavior on the internet, right? There's truthful QA, which is the response I'm getting accurate or truthful? Is it hallucinating? It's hallucinating a lot less than base GPT models. And we can also see, even in certain situations, it's kind of better for customer assistance. So we see that across a bunch of metrics, even though we don't specify what it means to be better at these things, just by having humans compare, we are improving on all of these metrics. Just for kicks, I used our vision model. I fed in the paper, the PDF, just pictures of the PDF, and I fed it to GPT and I asked it, hey, can you read and summarize it to me? So it actually does a pretty good job here. And I won't go too much over the details here, but it's another piece of proof that the vision models are starting to get quite good. And you can also kind of say, oh, can you explain the process described in figure 2, which is the one that I just showed you. So here, you can see that there's a reward model training step and then a reinforcement learning using PPO step, and then they are iteratively performed to train the final ChatGPT model. So just to reinforce what I just said, ChatGPT, the procedure for turning GPT into ChatGPT is to first fine-tune GPT with conversational data. So this way it kind of understands hey, there's an assistant interacting with the user. And then a reward model is trained by having humans rank completions from this model, and then we run RLHF, this procedure at scale. So now I want to move on to some results that have really started to emerge this past year. How do you make the most out of ChatGPT, and how do you extract the most reasoning from ChatGPT? Again, one of the criticisms is, these models they seemingly know a lot of information, but they make some small reasoning mistakes in ways that humans wouldn't make. So one of the big seminal papers here was an idea called chain of thought prompting. And the core idea is when humans solve problems, we often decompose tasks into simpler tasks, right? And then we solve each of the small steps before returning the final answer. But what we're asking our model to do often is to give the final answer immediately. So you can see there's a bunch of standard benchmarks in AI where there's, for instance, math word problems, common sense question answering, strategy question answering, etc. And you can see they usually consist of questions and then some kind of explanation before the answer. So typically when we prompt our model to solve these kind of questions, what we do is we give an example question, an example answer, and then we give a new question, and then we ask it to come out with the answer. And we ask it to come out with it immediately, right? So before the answer was 11, so now it says, okay, I see what the structure is. The answer is 27. But chain of thought prompting, what we do is instead of asking the model for the answer immediately, we show it examples of a person reasoning through how to solve the problem and doing the intermediate steps, right? So here, in our prompt on the right side, before we provide the answer, we actually show the mathematics and the step-by-step breakdown. And the model's like, oh, hey, I understand the format now. I should do some reasoning before I produce the final answer. And so we see that this makes the model much more accurate at producing correct answers, just by asking or showing it examples of doing reasoning. Here's a very cool plot. So this only works if your base model is smart enough. So on the x-axis here, across the plots, is the number of parameters in your model. And these are, this is a benchmark accuracy on the y-axis. And we see that, unfortunately, the labels are missing, but only after about a 50 billion parameter model does this chain of thought prompting work. So this is the difference between the blue circle here and the black line over here. So we see that, for small models, they don't really understand what reasoning is well enough. But once the model is large enough, all of a sudden, hey, I know what I'm supposed to do. I know I'm supposed to mimic reasoning, and suddenly the performance improves much more, right? So the model has to be powerful enough to become a good reasoner, and this kind of supports our GPT-4 hypothesis. Now, sometimes it's unsatisfying. Like what if you don't have examples of reasoning in the task that you want? Well, the answer here is also very simple. We can just add, let's think step by step to the prompt, instead of showing it examples of other reasoning. So what we do is almost this two-step procedure. We extract reasoning, and then we extract the answer. So you can see this on the left side. We have the chain of thought idea from before. So we show an example where there's reasoning, and then it mimics the reasoning. Instead, let's just tell the model to think step by step, and you don't need a previous example. And so the model will kind of say, okay, yeah, I know what I'm supposed to do. I'm gonna do some reasoning and really kind of organize it as steps. So you can kind of see this performs fairly well. And you can see that a comparison of different types of instructions to extract reasoning here. So let's think step by step is the best one. You can see some other ones that work pretty well, like let's think about this logically. You can also see some kind of counter style prompts. So if you have misleading prompts like don't think, just feel, these don't really improve the model too much. And irrelevant prompts, of course, like it's a beautiful day or something, that's gonna decrease the performance relative to the baseline. So before we tried searching over human-written reasoning prompts, one thing we can do is actually ask the model to write these prompts for us, right? Like why do humans have to try a bunch of these outcomes? So what we can do is we can start with a human-written prompt and then ask a model to come up with different alternatives that might work better than this prompt. So you're seeing in this diagram, a model will propose a bunch of different alternatives. We take the best scoring ones and then ask the model to come up with more things like this. And we can run an iterative loop. And the result is actually something that improves on let's think step by step. It sounds like a small improvement, but these things do matter. So let's work this out in a step-by-step way to be sure we have the right answer. That works better than let's think step by step. Now, how else can we imagine how humans solve problems? Well, sometimes humans don't just solve problems by themselves, right? If you go to a classroom, maybe you're in a classroom with other students. And the best way, maybe in that sense, to get a reliable answer is to ask everyone to try to solve the problem. And let's take the majority answer, right? So this is an idea called self-consistency. We just imagine we're asking a classroom full of students the same problem, with reasoning, of course, and then we take the majority of answer. So everyone reasons slightly differently. Some of them are correct, some of them are incorrect. Remember, these large language models are trained over the full distribution of the internet. Some are going to be incorrect. And we just take the most common answer here. So again, this improves the performance on reasoning tasks as well. And one other thing we can do on top of this is using debate to improve reasoning, right? Let's say you have a classroom of students now. Instead of just stopping at one round, why not have multiple rounds? So let's have a bunch of students try to produce reasoning traces, and then we feed what the different traces are back to the students, and they all reflect on it, and then they try another round of coming up with the solution, right? And the interesting thing you can see here is sometimes, both students get it wrong on the first try, but by seeing each other's work, on the next round, they both get it right. And the idea here is they can combine the parts of the solution that really made forward progress and just integrate them together, right? They often have this reflective capability. And so yeah, you can see, for instance, on the top left corner, two people are trying to solve this simple arithmetic problem, and they get it wrong on the first try, but then they converge on the correct answer. So we've seen a lot of examples in the previous section of how, just kind of by thinking, hey, what would humans kind of do in a certain situation? We can coax the model to improve its behavior. Now let me talk a little bit about GPT plus tools. This is another way to improve the performance of GPT models. Now one early notable example of this is WebGPT. And WebGPT is basically GPT with an external browsing tool, something that can look on the internet and basically get more reliable answers by virtue of having grounding in real web pages. So let me show you an example of what WebGPT looks like. So here, you can see if a user types in, how does a neural network work? It goes and it browses through. It clicks on web pages. It reads relevant paragraphs. So it's going and scrolling. It's clicking into other links. It's also going there and scrolling as well. And eventually it comes up with this answer that cites various sources, right? So this basically says that, why force your model to memorize all this behavior when you could have an interplay with external databases? And techniques like this help a model stay relevant as well. It's impossible for a model to know if every single restaurant, when it's open, when it's closed. And so tools like this allow us to interface with the real world in a reliable way. So there's also another important paper that came out this year called Toolformer. So models can solve new tasks from only a few examples, but they struggle with arithmetic and factuality lookup. That was one of the motivations of this paper. And their solution is to fall back on external tools for these types of problems. So for instance, if we have something like the New England Journal of Medicine is a registered trademark of, at this point you might want to issue a request to browse and figure out what this answer is from a database, and then just extract that answer and put it into the context. So how do you train a system like this? Well, we use the technique that we just discussed in the previous section. So we can ask the model to do it through prompting. So what we do is we take real input and output examples, and then we just ask the model, hey, where would you put an API call to browse the internet? Where would you use a calculator? And actually have the model just insert that for you where you think it would belong. So you can see here, if the input is Joe Biden was born in Scranton, Pennsylvania, the model will just know, hey, at this point before returning Scranton, I should probably make an API call. And then what we do is we fine tune on these calls and see which of them actually improves the accuracy. And finally, something that we launched earlier this year was plugins. And here, what the developer can do in this case is just simply specify a behavior that they want, and the model will decide if calling the API is appropriate. So this is actually a very lightweight way of introducing APIs into GPT, right? You just produce what's called a manifest document, which tells the model, hey, this API is used for this purpose. And the model will just read that and be like, hey, okay, I think it's an appropriate time to call the API. So I think two other notable recent tool use examples came out in the last month, and I would like to demo those very quickly. So DALL-E 3, also a project that I was involved with, and I would like to show you an example of what DALL-E 3 is able to do. So it's an integration with ChatGPT, and it generates images. So let me play. Oh. Okay, there is some sound, but I can just read it out. So we're trying to kind of create variations of a character in different settings. Great. So unfortunately, the sound is not working, but there's also a voice mode now that we launched yesterday. And so you can actually have the model narrate these stories, and you can speak to the model directly. And these are all implemented through a tool use. Basically, these are external tools that the model can call when it's appropriate. Lastly, I want to give a quick glimpse into the future. So there was this, I think, quite prophetic paper published from Percy Liang's lab called Generative Agents. And what they do is they create this 2D world where there's a bunch of agents, they can move around, and when they run into other agents, they can talk to them, they can have a conversation and interact. And what they do is they provide backstories for each of these agents. Let's say like this person, what are their characteristics like? What is their personality like? And then they just kind of unleash them into a world. And they find a lot of surprising emergent behavior here. Like it turns out a lot of the agents, they'll kind of come together and they'll say, hey, I'm planning a party and it's at this time. And they'll tell other agents and they all kind of converge in the same place. So we actually see a lot of human-like behaviors emerging just by giving people backgrounds and the ability to interact with each other. And they also have a reflection stage where people see all the observations and then they kind of bake that into their personality as well. Now I think this is a fairly undirected environment where there's no goal. But think about what you could do with reasoners, right, from the previous section. Capable reasoning models who are goal-directed. Like, could you imagine having your own agent interacting with other people's agents? Or let's say a company builds an agent, that interacts with your agent. And I really think the future we're moving towards is some agentic world where we can trust on the model's reasoning capabilities and have it act in our behalf on many times. Finally, I want to say a couple of words about OpenAI. So our goal is twofold. First, we want to build safe and beneficial artificial general intelligence. And we want to ensure that AGI benefits all of humanity. One thing that we care a lot about is safety. So we know that GPT models, they're capable of generating outputs that are untruthful, toxic, or reflect harmful sentiments. And these kind of things can be increasingly dangerous in a world where we have elections, right? A lot of kind of discourse in the public. And one thing that's notable is we used the 6 months after GPT-4 was trained to address these concerns by red teaming it with external researchers and users. So we did not launch it immediately. I think we spent a lot of time trying to make it more and more safe. And this really is the key to our strategy. We want to make state-of-the-art AI broadly available and easily accessible. And we think that this is the right way to allow people to adapt to the change that AI brings, right? Safety, you can't solve it by just sitting in a room and thinking about it. You really have to have the models contact the real world, have people adjust to it, and then to evolve the models and address all the harms that you currently see. So this is our strategy. We feel like we've done probably more than any other company to bring the most powerful models to people and allow them to use it. And we hope to keep doing that in the future. Thank you.
So we will set up the couch, and wait for a minute. So we will have about 15 minutes open for questions. All right, so now it's open for questions from the audience. Oops. Yes, please. Professor Chen from Tsinghua.
Hi, thanks for the wonderful talk. But I'm very curious about what are the compression you want to talking about. So would that be possible that you utilize like 10 minutes to talking about that? For example, what kind of the knowledge or wisdom you try to compress from the human language, the corpus, something like that?
Right. So I think I was trying to give some motivation of why we believe so much in scaling these models before other people did. And I think one of our motivations was from compression. So good predictors are good compressors as well. I think there's, from an information theory perspective, there's an equivalence there. And in some sense, like what the models are doing is they're searching over programs to produce a particular output. And I think in some sense, like kind of having the minimum shortest program that produces an output is the best compressor in a certain way. So there's a talk by Ilya, I think within the last month, where he articulates a lot of these points quite clearly. And I would refer to that one for a more detailed description.
Any other questions?
I think for the great talks, it's really impressive to see everything build up and also have this really strong feeling of iteratively releasing it, make progress and beneficial to the real world. So I'm from the computer vision community. So we went through building more than 1,000 layer model, but then realized it cannot be deployed and then go down through compression, something related to your topic. So I'm just wondering, do you think there's a bright future to make model much, much smaller, but still capable of doing everything that language can describe? Or what will be that future looks like? Do we can imagine that?
Yeah, that's a very good question. So all the evidence so far has suggested you need a base amount of capacity in the model to do really good textual reasoning. So if you want to lean on the textual reasoning abilities of the model, you do need it to be a certain size. But there's a lot of work actively in distilling these models into smaller models. And I think that's actually one of the most interesting research directions now. How do you make a small model act like a bigger model? And maybe it is something like chain of thought, like what I just talked about. Like perhaps you can imagine this big model as something that's very powerful and knows a lot of things, right? And a small model needs a lot of steps of reasoning to get to the same understanding. So I think it's an active research direction, definitely worth pushing on. But how do you turn bigger models, or how do you turn smaller models into the capabilities of bigger models?
Thank you for your talk. And as a professor or teacher, I'm interested in, do you think there's a corresponding between training and engineering ChatGPT with educating students, especially educating a child? Because training a model from scratch is very similar to educating a child. And do you have any experience, or you can recall anything between these two? Thank you.
Yeah, so I do have an almost 2-year-old. I guess it's too early to tell what the similarities are. But honestly, at OpenAI, I think this analogy holds a lot of water. You know, we see the pre-training phase where we're just kind of dumping a lot of data at the model as almost a kind of like childhood phase for the model. You know, it's just learning a lot of things. And maybe like kind of like teaching it reasoning is more of like an adolescence phase or something like that. But yeah, I think the analogy does hold water. And unfortunately, I don't have enough experience to give experiences from real life.
Hello. Hi. So my name is Sushanta. I'm from India. Okay, so thanks for your wonderful talk. And I have 2 questions. One related to the Edge AI or the Edge version of the ChatGPT. So, and another one is related to the generation of the code, the coding or the programming. Okay, so the first one. So now, is there any plan from OpenAI that there will be an Edge version or the smaller version or any quantized model that we can implement it on the embedded system? Okay, maybe this one first.
Yeah, I can't talk too much about our future plans, but it isn't out of the question.
Okay.
Yeah.
Okay. So the next one is related to the generation of the codes. So most of the as we know, this is a language model. Okay, not a coding generative something like that. But we do the generation of the codes and we get the help from there. But there most of the time we find that it fails after a certain level or. So do you have any comment on that, or is there any chance of improvement or something?
Yeah. So I do think, like you said, you know, there are gaps in reasoning, and also kind of as the length of the code increases, you're more likely to hit bugs. And I do think, you know, part of the issue is that humans also don't generate code character by character, line by line, right? There's a lot of iterative testing that you do. You complete a module, you try out certain cases, and you also hold examples in your head. So I think, you know, like kind of mimicking the human prior here should do a lot. And I don't think necessarily that means you have to move out of language. You can do stuff almost like we've seen with chain of thought, like, you know, hey, let's imagine simulating this input, for instance, right? So I do think a lot of these techniques will carry forward and really improve the abilities of these models. Yeah, with code in particular, I think one thing we showed in the Codex paper was various types of discriminators, meaning models that go and judge the full completion, the whole output of code, stacking that with the generators leads to much improved performance. And that actually isn't necessarily a given. Like you could imagine maybe like the model just thinks of one incorrect approach and just tries it all the time. But it turns out actually, it does try a diversity of approaches. And if you did have a perfect kind of model to pick out which one is correct, you can really improve the performance. So I think we're almost there. The model is able to come up with it often enough, and we just have to amplify it.
Thank you.
Thank you for your presentation. Okay, I asked the same question with different perspective. Okay, so after you train this big model, any way we can have compression? Okay, use your word compression and become like hierarchical and useful, effective for some. Small company have limited resource. This is another way thinking, look like mission impossible, but I still want to ask you, is any way after you training and you compressed like hierarchically?
Yeah, that's a good question. So our philosophy, I can tell you kind of strategically, what we try to do is we try to always ship the most intelligent models at any given point in time. So necessarily that involves building the largest artifact. But we've also found a lot of demand, for instance, with ChatGPT, right? There's a lot of usage that's, the faster inference version of it, right? And so we understand that's important. I feel like we'll invest more into things like that in the future. But we understand from a usability point, it's not that there's a lot of demand for the smart model, but also a lot of demand for fast kind of edge style models. Yeah.
Okay, thank you.
Hello. So thanks for the talk. I have two quick questions. So the first one, just wondering, all these are more language text-based learning. I wonder if if we can learn by observing the physical world. Does that make the model smaller, conversion faster, or do we still require amount of billions of parameters to get the same kind of reasonability that we're able to do that? Drop like apple, we know it'll fall. So that's my kind of first question. The second, on the usability side, just curious, right? It still requires a certain level of language ability, right, to be able to write that prompt, do that kind of thing. Is there a plan, or how does it, in the future, how do we see that it's being open to people that are maybe not as capable of doing that, but still get the same kind of services and tools, just out of curiosity?
Yeah, those are both really good questions. So I think on the first one, we're talking about kind of learning from vision. And one kind of interesting trend over the last couple of years is that the architectures people use for training vision are converging with the ones that they're using for training language, right? So like the vision transformers using very similar architectures to the text transformers. And my view is actually a little bit the opposite. So I do think it's probably easiest to learn a base amount of world knowledge from text, but at a certain point, maybe like the human text abstraction is no longer enough, right? And we have to start giving visual inputs, and the model can start looking at the world and making inferences for itself, not kind of filtered through this bottleneck of what humans have invented. So I do think, maybe in the future, to really go beyond text, we'll need to do a lot of unsupervised style learning from vision. In terms of kind of making the models more usability for people with different backgrounds, I think one kind of interesting thing with RLHF is it's the behavior you get is very sensitive to what the backgrounds of these kind of people who are ranking the completions are. And I think we've discovered that, maybe we should make this set very diverse, like have kids do this, and have people from, places where they aren't as literate do this. I think that could go a long way towards making the models kind of have the outputs that you would expect, even if you weren't as literate.
Hello. Thanks for the wonderful talk. And I have a question. It's like there are many concerns talking about the performance of GPT is dropping. Maybe it's due to the long exposure on the internet, or maybe it's because it's learning from the content that is generated by AI. So is that real? If if it is real, maybe does that mean GPT is not ready to completely live in the real internet world or something else? Thank you.
Yeah, that's a good question. So actually, I've seen a lot of articles of this form, like, oh, like it was deployed and then this month, like the performance dropped like 40%. So generally, a lot of that isn't accurate. I think if you see kind of the follow-up investigations, like sometimes they like tried some different formatting and it breaks the model in a certain way. We do try to be very rigorous when we deploy. There's a pre-training pipeline, a post-training pipeline, and we run extensive A/B tests before we deploy something to the general masses. And while I can't promise, like in every single benchmark, you'll never have a regression. Overall, we do find that we are shipping models that are more capable. And yeah, I think some of those news articles can be a little bit overblown. Yeah.
One question, please. There's any limitation of the knowledge amount of GPT can learn? Does it reach in the limitation of so-called knowledge amount, or there's no limitation?
So yeah, one of the great kind of discoveries in terms of GPTs are these scaling laws. So basically, you can predict very accurately, like if you keep scaling data, keep scaling the number of parameters, what is the level of performance? Basically, the amount of compressibility you can get at a certain scale. So far, we have not seen that trend break. And our intent is to push it until it does break, but hopefully it doesn't break. Yeah.
Okay, thank you.
Hi. Thanks for the talk. So previously, when GPT-4 was released, the blog post says that OpenAI decides not to open source. Hi. Yeah. It says that OpenAI decides not to open source the model, and I'm wondering, like, because for doing research, reproducibility is a very important factor. How would you recommend current researchers to do their research now that many other models and companies are following OpenAI steps and not open sourcing their models? And my second question is that what is your definition of AGI? Because it seems that every other famous researcher on Twitter has a different definition for AGI. Thanks.
Yeah, I think to the first question, right? There's a very tight rope that any kind of company developing these large language models has to walk. And one is, I feel like many researchers themselves are quite aligned with open source, but there's also a strong safety community, right? And I think when we did kind of GPT-2, some people were like, hey, like this is irresponsible. You can't open source this. Some people said, like, well, what's the danger? Like you need to kind of accelerate research. And I think we try to walk this balance by making things available, and then after a period of time, considering to open sources. And I think we will continue to follow this strategy. I know it's probably not the best strategy from a researcher's point of view, but I do think it's also important to be aware of and kind of be careful about the harms. Like at GPT-2 scale, we realized, hey, it wasn't really a big deal, and subsequently open sourced the model. I would venture to say, like even GPT-3 probably hasn't panned out to have long-lasting harms, and we may follow similar strategies there. I think to your second question, can you remind me quickly? Definitions of AGI. Yeah, I mean, of course, like AGI is always kind of a moving goalpost. There have been many kind of AGI tests over history. First was, the Turing test, and then I think Gary Marcus now has maybe like one test a month. And I do think, unfortunately, it is different even within OpenAI, right? Like what some people define it as, something that can accomplish economically valuable tasks at the same level a human can. But again, it does vary from person to person and a little bit in the eyes of the beholder. Yeah.
Yeah. Hello. Yeah, I have a question about the reasoning ability of ChatGPT that you believe in. So last day I asked ChatGPT to play a Go game against AlphaGo. Then how many parameters do you think ChatGPT needs to beat AlphaGo?
That's a very good question. Yeah. So one particular instance that's not Go is chess. I remember seeing on Twitter that someone tried the chess kind of just like native text chess, against GPT-4, and it was somewhere like 17 or 1800. Yeah, it is hard to say, right? Like, so sometimes these abilities, they kind of suddenly shoot up like chain of thought. So it's hard to estimate, but we do see kind of predictable scaling in most cases. So unfortunately, it's hard for me to answer. But.
Thanks, Mark, for being here with us today. I have a couple questions. The first one is, from my experience when I was working with simple neural network, after training, some of the connections and parameters are sparse or close to zero. And to me, at least intuitively, I feel that sort of can be an indication of like how much smaller the model can be, like in terms of compressing the model and things. I'm curious, like when you guys are working with GPT at OpenAI, is there any sort of insights or metrics you guys see that can lead to an estimation of how much smaller we can make the large language model? So that's my first question. Mm-hmm. My second question would be, like, is there any work in the future or currently that's teaching ChatGPT on how to ask the right question? You know, like that can be, you know, for automatic science discovery, or like asking a person that the ChatGPT is talking to for additional context and things. Thank you.
Yeah, both really good questions. So I think the first one, sorry, it's hard for me to remember. Can you just give me like a quick?
Yeah, I'm just curious if there's any sort of metrics or.
Yeah. So I can give a concrete example, and this is from the sparse transformer paper. So one thing that we did there was we trained a dense transformer, right, without much inductive bias, and then we went in and looked at the attention masks, right. We found that oftentimes the model, even though it could attend to all positions, it decomposed into this kind of like row column style attention over the images. And so I believe strongly in approaches like this. We continue to do things like this at OpenAI. And so the idea is, like, give the model the flexibility and see what it uses and what it doesn't, and that can give you efficiency wins. I think, sorry, you need to briefly remind me.
Is it still relating to the first question, or you?
Yeah, the second.
Oh, the second question is that, is there any current work in line that's sort of teaching ChatGPT on asking questions that actually look out, go into the real world and look for information and data and samples and things?
Yeah. So actually, we care a lot about data collection. I think ChatGPT is an amazing vehicle for data collection. I think just the volume of data we're getting in is immense, right? And we can think about ways of how we direct that data collection towards, the active learning boundaries of our models. So there's a lot of active research in that. I think we also care a lot about experts. So we've teamed up with a bunch of experts in, like mathematics, medicine, other domains, and they help us, interact with the model and tell us, hey, like qualitatively, these are areas of improvement. So I think that's another way to kind of drive at this. I think there's also very good data sets that are kind of rich in the style of questions. So for example, like papers, right? Like published papers. They often have, like very leading questions or interesting research questions that people ask. So just kind of figure out how to amplify that too. Yeah.
Hey, Mark. It's Jim from Yoling Foundation. So I was at the Monday Forum as well, and thank you for a great talk in both events. And my question is relevant to the gentleman at the front. So if you compare, OpenAI's solution with BART or other, what Tesla is doing, how do you compare the pros and cons and the accuracy or the commercial value in the future?
Yeah. I guess, now it's hard to have unified benchmarks, but I think there have been a couple of open source efforts that kind of like LLM leaderboards, and consistently, we still come out on top on the kind of open source leaderboards. At the end of the day, though, it's like what some of the recent papers have showed is, if you really want to target an LLM towards a particular capability, like you can get away with smaller models and like training on like very small and narrow distributions. So. But I do think you sacrifice a lot of generality, and you do need that generality for kind of extrapolation and reasoning. So we still take the approach of trying to create the most general purpose model. But yeah, again, like there's no kind of one gold standard benchmark right now.
Okay, thank you.
Hello. Okay. A lot of information on the internet has generally all rights reserved. So, what is ChatGPT's approach towards copyrights in general? There's a surprising amount of material that's not available for usage by the model, even though there are certain like online communities which merely treat it as a suggestion. This is more publicized. So. What is the approach towards that?
Yeah. So I think we want to play by the books, right? Like we have a large team of lawyers. We lean towards the side of kind of whenever we feel like there's ambiguity. So for instance, with there's you might have noticed there's this GPT bot kind of post on Hacker News a while. So when we were running our large web scrapes, we tell people, hey, look, this is kind of the traffic you can see, and this is how to opt out of being scraped. I do think in the U.S., right, the copyright law is such that like derivative content is not, you can kind of train on copyright content, and derivative content is okay. And I guess like my personal view is like, I guess we also take inspiration from a lot of copyrighted works. Like we will read a book, right? And we will kind of understand things from the book, and we'll create, right? And so, yeah, I mean, it's probably going to be an interesting legal landscape over the next couple of years as well. But I do think it is simplistic to be like, oh, like kind of, just because something is copyright means you can never kind of view it in training.
Understood. Thanks.
Hi, hello. Nice talk. I really would like to have two questions. The first one is about the how you are constraining the large language model. So, how much do you think that is we are far for having the scientific method inside of the constraint of the large language model? Right now, you mentioned something like the change of thoughts. There is a way to have a scientific method in the constraint and how the model is performing a hypothesis, looking for evidence, and accessing to the internet and trying to come around with a new understanding and new knowledge from that. How far we are for having that in the large language model? What is missing? And from your thoughts, what we can do?
Yeah, so I actually think you nailed the problem on its head. It's like right now, the model doesn't really interact with the world much and isn't able to carry out the experiments it wants to. And your suggestion of using tools, I think, is the right way towards that. So I think as we move more into this agentic world, right, where the model comes up with an experiment, and then it says, hey, now I'm going to interact with the real world and run the experiment. And then it comes back and reflects. So I think kind of moving to this agentic framework is the right first step, and also just giving it as many tools as possible. Yeah, right now I think it knows experiments it wants to run, but it can't actually do them.
Oh, okay. And I have a second question. So from the large language models, when we are training to predict the next word and having large amount of data in that embedded in that model, these emergent properties of new thoughts or prompting the model to make some directions, it's kind of how the human brain is thinking or is conceiving the world. What are the lessons that we can learn from the large language model to our own intelligence as a human species? Is there any lesson that we have learned from that? Or is it always from what is something similar to human beings, but it's nothing that we can learn from the large language model, like behavior, that we can learn as a human species about our own language, our own thoughts? Do you have any thoughts about?
Yeah. It is very interesting. It's like the way that the models learn is still very different from how humans learn. And so I don't know if there's kind of any experiment where we've done some kind of like neuroscience, maybe that's like a loaded term, but like on our language models and had it generalized to some kind of process for figuring out how humans' brain work, unfortunately. But it is very exciting. Like I wish we had more progress in doing things like that.
Thank you.
Thank you for your impressive talk. I have a question based on the previous demo of DALL-E 3. So I'm wondering what's your perspective on possible direction of multi-model development, since as for DALL-E 3, it already used like voice image tags that the common sensory inputs. So I wonder if it's like you just mentioned about maybe we should take more information from vision, for example, video or motion clues or optical flow, etc. Thank you.
Yeah. That's a great question, because I feel like one of the things that makes multimodal so exciting is, unlike kind of language models where we've more or less kind of converged to a base architecture, it's still very much the Wild West, right? Like there's diffusion models are gaining in popularity. Potentially GANs are coming back and rivaling diffusion models. And so there's a really big space of model architectures to try out there. I think it's a great place to do a lot of basic research. We do a lot of it ourselves in-house. So like Yang Song, who has been pushing kind of a new class by himself called consistency models, kind of a close cousin of diffusion in motivation, but actually quite different. So I think it's quite exciting. It's one of the biggest reasons I love working on multimodal.
Okay, thank you.
Okay, thank you for your talk. And I just want to ask that how far are we from AI integrating into our world seamlessly? Like you don't even know that's AI, and to what extent do we trust this AI so that it's capable of doing this, and to like not too much so that we overly rely on this AI?
Yeah, that's a really good question. So I think the reality is AI is already in our world. I think when we look at collecting data these days, we can actually detect that a lot of it was AI generated. And I do think the fact that we've released things in this iterative way, like people are aware that AI is in our world, AI content is in our world, and I think kind of people have to adapt their mindsets also to kind of have this prior that when they see some information, like it could be AI generated. So I think that's a very important part of it, just the education, kind of the gradual soaking in. And you had a second part of your question.
So the trust part.
Yeah, trust. So I think it's like a multi-dimensional problem. Like I think one thing is like you can't build AI just for like one demographic or one type of person. So I think having customizability is super important. I think actually like kind of handing off control to the user in many cases is also very important, right? Like the user should be making the key decisions. Like it should feel like a tool that's aiding you, and the model should be able to explain to you what it's doing, right? It should be like in the chain of thought world, right? It's like you want to know what the model's thinking and what it wants to do. So I think so many different things to explore, even from the interface side. But I do hope we can trust these models more.
Hi, thank you for the time. So following up from the previous question, I've been wondering, is there have been any measures that have been taken by OpenAI to actually prevent the misuse of ChatGPT and from the articles it produces from creating fake news to the public, especially when we see from your presentation that was until now from the research, GPT-3 models has the lowest articles produced. That was 50% to the distinguishable fake or not fake news. Thank you.
Yeah. So we have online monitoring for usage all the time, right? Like we're always kind of looking live. What are the usage trends? What are people using it for? And we set out strict content policy as well. It's like there are kind of currently, like if you want to have a relationship with GPT, we restrict kind of use cases like that. And we try to be very careful about certain dangerous territories and we spell that out in a content policy.
So hi Mark, I have a question about how ChatGPT you prevent ChatGPT from generating harmful and toxic contents. Like if you let ChatGPT interact with real world, if this you can't be human supervised. That's to ensure that ChatGPT won't generate any harmful and toxic content. So how does OpenAI make sure that? So yeah, that's my questions.
Yeah. So there's a kind of two-pronged approach, right? There's some very, very harmful content and very bad content, like maybe like child sexual content that you just prevent by default. And you prevent it in the content policy, you block it in as many ways as possible. And then I think when it comes to kind of toxicity in the more general setting, it's very hard to precisely spell out what that means. So we use the RLHF approach, right? And we really have humans kind of grade these things and guide the model away from the space of harmful generations. So it's, unless you can really spell it out in words, and oftentimes for the most egregious content you can, you have to rely on these softer metrics like RLHF.
Thank you.
Hi. Thank you for a lovely talk. So here I have 3 questions, I think. First of all, so the previous questions mentioned about the similarities of artificial intelligence, the neural network module, and the human brain. So is there some planning research of applying the techniques in neuroscience in the training of artificial intelligence? The second question is,
maybe I can answer that question first before I forget. Yeah, so I do think this is still a very active and exciting area of research, but in general, recent attempts to take things that are biologically inspired and to build kind of their digital equivalents haven't been as fruitful as they have been. So I think what has been interesting is kind of trying to do interpretability work on the neural nets themselves. And there's really good work from, for instance, like Chrysola, showing that you can actually interpret some circuits within the neural network. Like you have a car detector, and it's like composed of a window detector and a wheel detector, like convolved in a certain way. And I do think that kind of stuff is very exciting.
That's kind of like how neuroscientists split the human brain into some areas for different responsibilities, something like that.
Yeah, yeah. Oh. Yeah, so the interpretability work does try to do that. I think one difference, maybe some neuroscientists should tell me if I'm wrong, but one difference is that there's a lot of redundancy built into neural networks. So even if you say, hey, like this is responsible for this kind of behavior, when you kind of do like the knockout experiment, often you find that like the behavior is also baked in somewhere else. Yeah, it is a little bit hard to say like, hey, this compartment is responsible for this and that one's responsible for that.
Okay. So the second question is, you mentioned that to kind of filter out the toxic content. So the term toxic itself is already very vague. Like, for example, if I want to create a fake story, if I want to create a fake news, I can tell ChatGPT and say, oh, I want to create a story based on some real events, but it's not true. But in the end, I use these content to kind of like publish that as fake news. So it has a lot of real life examples of these kind of events. So is it really possible to say filter out all toxic contents? So like the current approach of RLHF is just a temporarily measurement. So is it actually working to make the model better?
Yeah, that's a good question. So I think it does a lot to make the model quite a bit better. We don't think, I think no one at OpenAI thinks RLHF will be the final algorithm for doing this. So there's a lot of active research and I think we should target eliminating it. It's just RLHF is what we have now. Yeah.
Okay. So the final question is, a lot of articles are mentioning about the financial situation of OpenAI. So, if I remember right, the current financial income of OpenAI, especially for ChatGPT, is from the what's it called, the membership, is it called like that, and the money big companies pay for. So is it actually, does the financial okay, is this the stable financial model for keeping the company alive?
Well, yeah, I can't comment on our revenue numbers, unfortunately, but we do continue to receive investment, and we're very optimistic in our outlook. Yeah.
Yeah. Should be no problem at all. Yeah. Any other questions? Yes.
Hi. I have one more question about safety. And yeah, so what kind of restriction do you have on religious content? Do you ban ChatGPT on it, or have some kind of strong rule about it?
That's a good question. Unfortunately, I'm not the right person to answer. I'm sure there's something there, except I do research in multimodal reasoning, so I think someone else sets that policy.
Yeah, thank you for the talk. And I'm curious about what's your opinion about hallucination. Since it have a safety issue, but it's not human injected into there, but it's a model output something that may be harmful. And this maybe since ChatGPT is already very trustworthy, so if he says something wrong or dangerous, then people may take it as a truth and try to do it. And I am curious, what's the long-term or future approach that OpenAI may take to address this issue?
Yeah. So I think there's a couple of reasons hallucinations arise. So one thing is, again, like people, we train on text that people write on the internet, right? And when people don't know the answer, people don't usually waste the text to write down that they don't know the answer. So a lot of the training data, right, it confidently plows forward, right, towards answering something. And our models kind of inherit that behavior because humans very rarely, they say I don't know, but they don't often write I don't know. And so it's kind of like giving the models this capability to be calibrated and often say I don't know when it doesn't know. I think that's one important thing that we want to give it. Another thing is I think the reasoning also helps a lot with hallucinations. So the more that the model can kind of reflect on what it's trying to say, if it sees any logical fallacies, right, then it can eliminate certain types of hallucinations there as well. And I think the third thing is just kind of browsing and retrieval. So the more we can lean on kind of stuff like a web page, right, that tells you the accurate information, and we can maybe do some consistency there, right, like look at 5 or 6 reputable sources. I think this kind of stuff will help reduce hallucinations.
Okay, thank you.
About 10 more minutes, so maybe the last 3 questions.
Hi. Hi, I'm here. Thank you for being with us today. I have a question. I think the usage of the ChatGPT nowadays is like, for example, I got a mathematics question. I asked ChatGPT and I close the tab. It is in a short period of time. My question is, I think, is is ChatGPT have the ability to learn the context of the whole conversation. For example, if I want to build a chatbot that can memory what I say in the long-term memory, I think that ChatGPT is now currently lack of this ability to do this. Is there any progress or methods to do this ability?
Yeah. So I think long context is a very big research direction, probably across all of the labs. And I think even with GPT-4, we've released long context versions of that, which developers are using for persisting information. And I do think tool use is another way to kind of persist that information. So if you kind of build tools or plugins that can retrieve from external databases, that's another way to kind of have long-term state on people.
Yeah. Okay, thanks.
Hello. Hello.
Hi, Mike. Because for your PowerPoint, you talk about you use reinforcement learning to improve the GPT. So I want to ask about if our lab don't have such a big model, we only use a small model. Maybe we can't provide a good environment for reinforcement learning, but whether I can use the reinforcement learning to improve my model to make the agent perform better. Yes, at all.
Yeah, I mean, probably in the language modeling setting, it's a little bit more difficult, but I mean, reinforcement learning has been hugely successful in kind of narrow domains. I think it's just a lot of the work that we've done in the past. I think there is a MarkChen paper we published a while back. It's like if you try to create a diverse kind of agent that you try to train with reinforcement learning in a diverse amount of settings, you really need a lot of kind of training data for that. And so I do think if you have like a narrow, well-defined environment, you're still able to do that at small scale. But scaling it to a very diverse set of environments, it's a little bit harder.
Oh, okay, thank you.
Hello, Mark. Thank you for your wonderful talk. I am also from India. So I had one question regarding one of the slides, which was the chain of thought prompting. So how do you can you just explain it in simple terms, like how it is built into the model, like you showed in Lambda, Palm, and etc., those models? And just a basic, yeah?
Oh yeah, so this is pretty model agnostic. Yeah, basically, I think any language model you're able to apply chain of thought to it. So very simply stated, it is before giving the model a question, you show it another related question and a long reasoning trace that produces the answer. And the model, just by virtue of prompting, will try to mimic that same type of behavior in producing the next answer. So it is kind of like the agnostic of whether it's Palm or some other type of model. Any language model should have this capability.
Am I audible? Yeah. So is the thing you said about small models performing giving good performances compared to larger models, so can transfer learning also play a big role in that? Like when we compress the models and still it's giving us a good performance? Yeah.
I mean, I think transfer learning, I see it a little bit maybe as like an orthogonal thing. So, transfer learning will help your big models and your small models kind of equally. There may be, I should reflect more if there's some kind of a distillation angle to transfer learning, but nothing comes to mind right now. So.
Right, I think there's one more over there. So that's the last one. Over there in the corner. Yeah.
Okay, thank you for giving me the last question. So there's a new attack method against the LLM called prompt injection, where the attacker tries to trick the model to output what they want. Like a couple months ago, there are some users tricking the Bing chat from Microsoft to output the activation key for Windows 10 and Windows 11 by phishing for sympathy. And so what's the approach from OpenAI to protect your model or like ChatGPT against these kind of attacks?
Yeah. Honestly, even RLHF as a base technique, continuing to tune on that is quite a good defense mechanism. And I think over time what we've seen is that the prompts that you need to do to get prompt injection to work have become more convoluted and more kind of like involved. And ultimately, I'm not sure this is the right necessarily attack vector to defend at even at this point in time, because you really have to like want to like it's not like you accidentally kind of have a prompt injection attack, right? Like you really have to be a malicious user to come up with the strings that you need these days. So in some sense, like you're already violating kind of the content policy. So I do think, at this point, we'll continue to make it harder and harder, but it doesn't feel as relevant of like a user won't accidentally produce this behavior.
Okay, thank you.
Actually, I have a question for myself. So have you ever thought about how these AI tools like ChatGPT or can shape future humans' future life? Have you ever thought about this?
Yeah. I mean, I think from my own personal perspective, I see it as a very useful tool today already. Like I use it in my daily coding, so it helps me, very effectively catch up to, let's say, some new framework that I don't know. And even as an educational tool, I feel like it's very useful for me as well. Like if I want to learn something in biology or in chemistry, like it's often easy for me to have this conversation, right? And it allows me also to kind of like drill into the questions at the right level of depth. So I do think, for education in the future, it'll be very useful, kind of as a companion for learning something like coding. And I do think one underrated use case is also just kind of conversation. A lot of people are lonely in this world too, right? And it could be a good conversational partner for people and kind of have that state and try to maybe put you in a better mood or something like that.
People are really afraid that they will be replaced, the job will be replaced by robots. So you have any comment on this?
Yeah, I mean, it's with technology, right? I mean, there's always uncertainty in the future. And I don't think like brushing that under the rug is the right approach either. But right now, it is most useful as a tool. And I think we also can lean on the regulatory frameworks. Like this is a lot of what Sam Altman did his world tour for, like setting up the right kind of frameworks to make sure that, we're developing a right ecosystem, right? And figuring out kind of what level of responsibilities the AIs can take on, right? So I do think I trust in the world to kind of regulate the AI in a way such that we're preventing massive job loss. And honestly, I do think, generally I'm tech optimist. I am optimistic about a future where we have more tech. And I think that's generally been the pattern in history too. Tech improves our lives.
So I think it's 3 o'clock. So let's thank Mark again for this very wonderful talk.